Okay, so here are the notes for 5-1. This is going to be our factoring unit, okay? So the first day, the title is Factoring Completely, day 1, okay? So let's look at the first one. If you remember back when we did factoring in the fall, we had 3 different steps for factoring, okay? So our first step, I'm going to write it over here on the side just so we know, is to get their greatest common factor, okay? GCF, greatest common factor. Our second step was going to be difference of squares. Okay, looking for difference of squares. Our third step was if you have a 1 in front of the x squared, in the form of ax squared plus bx plus c, right? Your quadratic. If you had, if your a was equal to 1, then you could factor mentally. Okay. But if that's not the case, if a wasn't 1, then you go to the fourth step. Okay, I guess there was 4 instead of 3. Where when you have ax squared plus bx plus c, and a is not equal to 1, so it's something other than 1, greater than 1, you're going to have to go through that whole process where we multiply the first and last term together and then factor. So multiply first and last terms to find factor that when added together equals the second term. Okay, we're going to go through these in detail, but I want you to be able to think what your thought process every time you're looking at the problem. Okay, I'm going to be going through these steps each time in my head, okay, mentally. So by looking at number 1 where it says 4x squared minus 25, greatest common factor, do these have anything in common? And they don't, okay? There's nothing between the 4 and the 25 that they have in common. Difference of squares is a squared minus b squared equals a plus b times a minus b. Okay? Now, this could, in my head, I would think this is definitely a possibility of being ax squared minus bx squared because I don't have a middle term, right? I don't have the bx in the form. All I have is the ax squared minus the c, okay? So that fits this format because this format only has 2 terms and it has a minus sign in between. So now I have to figure out, can I take the square root of this function and can I evenly take the square root of this function? Yes, I can, right? The square root of 4x squared is 2x and the square root of 25 is 5, right? So my a is equal to 2x and my b is equal to 5. So now filling in this formula, this is my factor. I would just write 2x plus 5 in parentheses and 2x minus 5 in parentheses. Okay, so all I did was find my a and find my b, and now I'm plugging it in this factoring equation. Okay, so I have a plus b, a minus b. Okay, so now let's look at number 2. Do they have something in common? Yes, they do. They both have 4 in common, right? So you can take a 4 out, and they both have an x in common, so I can take an x out. So that leaves me with 16 divided by 4 is 4, and x squared divided by x is x, and now 4x divided by 4x is 1, right? So plus 1. All right, so now here is my parentheses, this isn't even a quadratic equation anymore, right? It's 4x plus 1. The 4 and the 1 don't have anything in common, so I can't reduce it any further. Okay, let's look at number 3. So greatest common factor, do these numbers have anything in common? No, they don't. The factors of 3 are 3 and 1. The factors of 7 are 7 and 1. So these two don't have anything in common besides 1. All right, so 2, difference of squares. Remember, this is our difference of squares formula, okay? Does it look like a squared minus b squared? No, it doesn't. There's 3 terms here, and there can only be 2 terms. So immediately I know it's not difference of squares. So number 3, ax squared plus bx plus c. Does the number in front of my x squared equal 1? No, it doesn't. So I can't do so it doesn't apply for number 3. So now number 4, ax squared plus bx plus c, where a is not equal to 1, which is true, okay? So now this is where you have to take your first and your last term and multiply them together, and you get negative 18x squared, right? Okay, so now I'm going to take my 18 over here, and I need to find my multiples of 18. My factors of 18. Say multiples. My factors of 18. 18 and 1. What else do we have? 9 and 2. 6 and 3. Is there anything else? Okay. All right, so anyways, our middle, we need to be able to add or subtract and get 7. So if I subtract 1, I get 17. If I add 1, I get 19. If I subtract 2, I get 7. And if I add 2, I get 11. And this one's, if I subtract 3, I get 3. And if I add 3, I get 9. So it only works for this one. And if I need it to be negative 7, then I would need to have my 9 be negative 9 plus 2 would give me negative 7. All right, so now I'm going to rewrite it. My first term stays the same. So I get 3x squared. Now I have negative 9x plus 2x minus 6. So my first term and my last term stayed the same. And my 7x now became this. So this right here goes to my 7x. All right, so now I'm going to put parentheses above my first 2 terms, parentheses around my last 2 terms, and we're going to see what they have in common. So find their greatest common factor. So the greatest common factor between this parenthesis would be 3x, and that would leave you with 1x, and it would leave you with minus 3. Okay, now this one, what do they have in common? A 2. So you would take a plus 2 out, and you would be left with x minus 3. So now your parentheses match, okay? So now when you rewrite it, everything on the outside of the parentheses you're going to put together. So 3x plus 2, it's this one and this one. And then whatever you got that matched in parentheses, you just write it once right next to it. So that's the answer. Okay, let's look at number 4. So back to our steps. Greatest common factor. Do they have anything in common? They do. They're all multiples of 7, right? So take a 7 out. You're going to be left with x squared plus 4x plus 3. Okay, now your 7 stays the same, but now this we can still factor. Okay, and if you're looking at your factor steps over here, you have a 1 as your a in front of your x squared, so you can factor mentally. So that means you have to take your factors of 3, which is just 3 and 1, and they need to add or subtract to get 4. Yes, this works. 3 plus 1 gives you 4. So that means it's easy. Factor in your head, you just have x and x, and now you know it's 3 and 1, and they're both positive. So that's your answer. Okay, so our first step was pulling our greatest common factor out, which was 7. And then we just factored mentally. So we just found our factors of 3 that we could add or subtract to get 4. Okay, we're going to do one more, 5, and then we'll do the next 5 tomorrow. So first off, greatest common factor. Do they have anything in common? Yes, they all are multiples of 8. Okay, they all also have an x in common, at least one x, right? This one has an x squared, and an x cubed. So at least one x. So we're going to take an 8x out, and it's going to leave you with x squared minus 6x. You're going to get plus 9 end parentheses. Okay, so now the 8x is going to stay there. Can't do anything with it once we pull it out. But now looking in this parentheses, do these have anything? Can we factor this? Yes, we can. And this falls into number 3 up here, where we have a is equal to 1. So you have a 1 in front of your x squared right here. Okay, so that means you can factor mentally. So that means you're going to take your factors of 9, which is 9 and 9 and 3 and 3, and you need them to be equal to negative 6. So that means they're both going to have to be negative to make negative 6, right? So that means you factor mentally, you would have x minus 3, x minus 3. Okay? All right, so look over those, rewatch the video if you need to. It's important that you understand these first 5 before you move on to the next 5.